G'day YouTube, welcome back to the VK8 FOAS YouTube channel. Today we're going to be visiting a bit of an old favourite of mine and many people who view my content on my channel. We're talking about GSM decoding again. More specifically, we're going to be looking at this interesting project that one of my viewers sent me via email. It's called GSM Assessment Toolkit. And the way it works is it's kind of like a wrapper around GR-GSM. Sort of in the same way that GSM TK is a wrapper around Osmocom BB. It's got heaps of really cool features. Again, I haven't played around with too many of this stuff yet. I've just got like the basic things working, like scanning, capturing, decoding, and a few other bits and pieces that I'll show you guys later. But yeah, you guys can have a look at this in your own time. It's got a Wikipedia as well, like really good documentation. It's hard for you guys to see behind my camera, but yeah, it's got like step-by-step instructions how to achieve like all of this kind of stuff. So yeah, very interesting project. So thanks to the viewer who sent it to me. I'm always dubious of like these old GSM decoding tools because, you know, everyone knows that GSM's obsolete and not many people work on it anymore. So these tools are always generally quite old. This one hasn't had any updates since 2017. So it doesn't really run at all on newer versions of Linux. So I'm using an older version. So I'll talk about that in a second. So yeah, as I said, it's quite an old application. So I'm using Dragon OS LTS, which is built on Ubuntu 18.04. Of course, Dragon OS is made by a good friend of the channel, Aaron from CM Executor, so thank you to him for this awesome version of Linux, which is really good for running old tools on. So this is my go-to for running like old and outdated tools that won't run on newer versions of Python, for example. I'm kind of cheating, as you guys saw before. I'm kind of using virtualization for this. But everybody knows my stance on virtualization. I hate it. It sucks when you're doing when you're using USB pass-through to attach SDRs to them. It's absolute garbage. So normally I always run Linux on bare metal. So bare metal means like it's installed natively on your PC's internal hard drive, or you can be like me and then construct bootable USB drives with a Linux installation installed to it. So we're going to need some hardware for this as well. So I'm using just my very old blog. This is the first SDR I ever acquired. Blog V3 rtl-sdr. Cheap, but really good. I highly recommend it for working with GSM. Obviously, if you're working with hopping GSM base stations, it's not really going to work for you. But if the base stations in your area are non-hopping, so they're just like a single 200 kilohertz wide channel, this is all you'll ever need. Oh yeah, I should also mention too that the base station has to be 850 megahertz or 900 megahertz band, as this rtl-sdrs only go up to 1700 megahertz, so 1.7 gigahertz, and then after that you've got your 1800 and 1900 megahertz GSM band. So yeah, just remember that if you're going to purchase one of these. And for the antenna, I've just got a telescopic antenna, and it's just literally sitting right behind the camera there on top of my PC tower. So yeah, if you guys aren't really sure what GSM is or what 2G cellular is, I've got heaps of playlists on the topic of that. I've got stuff about Osmocom BB. We've got GR-GSM how-tos here. We've got a decryption playlist. And we've got like Rogue Base Station playlist here. And then we've also got a Kraken GSM Cracker how-to as well. So yeah, if you guys want more information on that, go and check that out. Okay, so I've got my environment all set up here already, but if you guys haven't done so, we're gonna need to open a terminal window. like usual. And we need to install some dependencies. So you guys can do that with this command right here. So I've already copy and pasted it, but I'm just going to hit enter on that. Just let you guys know, you'll also need a internet connection for this. If you're fetching packages with APT, you need an internet connection. And then the next command we need to run is the one to actually clone the program files from GitHub into our home directory. So I'll just hit copy and paste that command and hit enter. And we can see that we've got a folder here in our home directory called GSM Assessment Toolkit. So I'm just going to call it GAT from now on. And then that's it. That's really all you need to do. It's really simple to install. It's really cool. So we need to generate the config files, and this is an automated process, right? So I'm going to just run this command, and then when I launch this Python script, which is the GAT executable, essentially, it's going to create the config files in a hidden folder, so we won't even know what's happening. It's all completely automated. And yeah, that's what happens when you run GAT. You get like this nice ASCII picture thing. So yeah, it's pretty cool. I'm actually going to send it the quit command because the first feature I'm going to demonstrate for you guys is we're going to scan for GSM base stations, because if you don't know the frequency of a GSM base station, you've got nothing to decode essentially. So I'm going to copy and paste this next command to launch GAT again. And this time you'll notice that I've actually got sudo at the beginning of this command. So for some reason, scanning only works with elevated admin privileges for some reason. All the other commands do not require sudo. So I'm just going to hit enter on that. And don't forget that I always configure my Linux distributions to never prompt for a password, because it's just a virtual machine. I don't really care if something malicious happens to this. But if you use Linux as your daily driver operating system, I highly recommend against this. Okay, now that we've successfully launched into GAT, we're ready to actually scan for GSM base stations. So I'm just going to double check and confirm that my rtl-sdr blog is attached to my virtual machine, and it is. And then I'm going to hit enter on this command, and hopefully it should discover my Yate BTS based base station. And there we have it. It is found. I'm just going to quit this command now because I know that there's definitely no more base stations to be found here. So I've got this base station set very low power, and it's inside my backyard shed, right? So the RF is not going to propagate too far from my property and cause destructive interference to any other services operating on that frequency. Okay, so every time you run a GAT command, you've actually got to exit it again, because it's something to do with like it keeps the port open that it uses. So we need to actually, so if you try and run two commands one after the other, it'll actually throw an error because the port is currently in use. So I'm going to quit GAT. So the next thing we're going to do is we're going to actually capture some data. So as you can see here, I've already got a capture file here, and you'll notice that it's actually a different format. We've got BFILE here. So I'm going to explain what a BFILE is later, but just ignore this for now. So this is just a capture file that I made to generate some traffic to demonstrate some features a bit later on in the video, but just ignore that for now. So we're going to create a whole new capture file now that we know that there's a GSM base station operating and we can receive it. So I'm going to run GAT once again, but this time you'll notice there's no sudo at the start. And I'm going to hit enter on that. If you haven't done so already, we need a second terminal window now. This is completely optional, but I just want to show you a really cool feature. I'm going to, so people will know this people will, this will be very familiar to some people. So I'm using T-Shark here just to view the GSM packets. T-Shark is not included in Dragon OS LTS by default, so you guys will have to install that in your own time. I'm just using T-Shark in the terminal because I've got limited space on my screen here, as you can see, so I'm just going to do everything in the terminal to keep it neat. So I'm going to hit enter on that command, give it a couple of line breaks there. And now we're at the stage where we can talk about what a BFILE is. So a BFILE is, it's an old feature that has been removed from newer versions of GR-GSM, but it still retains the feature to decode BFILEs in the newer versions, but older versions had the capability to record a burst file. So a C file is like an actual IQ recording of the radio waves in the air as received by a SDR radio, whereas a burst file or B file is literally just the raw GSM bursts being written to the file. So it actually keeps the file size down. So a lot of people back in the early days of GSM decoding used to use the BFILE format as a form of compression, because instead of having a 5-10 gigabyte C file, you could probably just have a 200 megabyte B file. So yeah, people used to use it like a crude form of compression to keep their capture files down, or the file size of the C file down. So I haven't figured out how, and here's the bad news, I haven't figured out how to decode C files with GAT. Handling of C files, even though the Wikipedia says it can handle it, I haven't figured out how to do it yet. So all your old C files will pretty much be useless with GAT, unfortunately. So I haven't figured out how to do it yet. Maybe you guys could figure it out, and then you guys can let me know. And yeah, here's the help file of GR-GSM, and you can see that the decoding functionality of B files still exists in there somewhere, even though it's been removed from the capturing utility, unfortunately. I'm not sure what the reason for that is. I'm sure there is one, but okay. So now that we've established that we can only decode B files, that means we have to capture B files. So I'm going to copy and paste this command here. Again, there's no sudo when I ran the GAT launch command, of course. And this is the command I'm going to be running. So I know for a fact that the ARFCN channel is number 1. The band is PGSM. That's just your regular GSM band on 900 megahertz. It starts at about 935 megahertz. And you have to use full paths as well. Like you can't just put this thing to designate your home directory. You actually have to write home / your username and then / capture, if that makes sense. So I'm going to hit enter on that, and I'm going to show you guys a really, really, really cool feature of this thing. So can anybody figure out what's so cool about this? So, you know, when you guys capture with GR-GSM capture, you don't even know anything's happening aside from seeing a file in your home directory grow larger. GAT is actually printing the raw GSM bursts, and it's decoding them for us while it's capturing. I just think that's really cool. So I'm just going to leave that run for a while. I'm going to take a drink, and yeah, we'll capture some data. So yeah, it's very cool to see the decoded traffic as you're capturing it. And this is a really good method of making sure that you're actually capturing data, instead of just running the capture command and then maybe there's a problem with your SDR because you're using it in virtualization and it's not writing any data to the file, like what happened in my video, my Yate BTS part 3 video there, if anybody's watched that. I had problems with passing through an SDR to my virtual machine, which is always very buggy and glitchy for me on all my machines. So, okay, that should be enough data now. And to quit, you just press the Control C. And then, yeah, we can see after capturing all that time, that probably would have been 300 megabytes of file size if we were capturing a C file. It's only written 23.3 megabytes to the file. So yeah, it keeps such a pity that they don't have this burst file feature anymore in GR-GSM, but oh well. Okay, I'm going to quit that now. So I'm going to quit GAT again, because remember we can't run consecutive commands, unfortunately. Otherwise we get the port is in use error. And then the next thing we're going to do is we're actually going to, so we're not going to decode that capture file we just recorded. I'm actually going to decode this one now because there's been some traffic generated on it from my 2 smartphones. So once again, I'm going to run the GAT command, launch command. Clear that. I'm going to show you guys just decoding some SMS messages. So yeah, in this file here, call_SMS, I sent some SMSs to myself. So yeah, but just remember though, GAT is not going to allow you guys to read encrypted SMS messages, right? Like this traffic was recorded from my Rogue 2G base station, which doesn't use encryption, okay? So GAT is not this magical thing that's going to allow you guys to read other people's text messages, okay? You have to do the cracking as well, which GAT does perform, but I haven't figured that out yet, unfortunately. Okay, I'm just going to run this command here. So I've just configured T-Shark to just show us SMS messages, okay? And then I'm going to use GAT's decode command. And I'm going to decode the SDCCH4 channel on time slot 0. And this should print the bursts in the top terminal window, and in the bottom terminal window we will get my SMS messages. So I'll just hit enter on this. And there we go. We've got 4 SMS messages appearing in the bottom terminal window. And if we go back to our T-Shark, you'll see the decoded packets here. So yeah, that's a very, very cool feature. So they're like the 3 big main features. So now there's another cool thing that you can do with GAT, and that's analyze. So you can extract like various pieces of information like TIMSIs and like the base station system information, and like you can get a list of like all the immediate assignment packets, and yeah, it's actually really, really cool. So again, I'm going to quit GAT, and then we're going to relaunch it again. And then the first command I'm going to use is system info. So I'm going to copy and paste that, and then I'm going to hit enter. Sometimes it takes a little while because it's analyzing the B file, and it's going to extract the data that we want out of it. And yeah, there we go. So we've just got like information like what the power level is, what the ARFCN channel number is. We've got frequencies, we've got MCCs, MNCs. If you're using a real GSM base station, this will probably say SDCCH8. Sorry, this will just say just BCCH. Sorry, because I'm using the 8BTS. It actually uses a combined broadcast and standalone control channel. And then, yeah, then we've just got like and the neighbor ARFCNs and stuff like that. So yeah, very, very cool. So the next command I'm going to show you guys is, might have to quit. I'm not sure if the analyze will throw that error, but I'm just going to quit anyway, just in case. So now we're going to analyze immediate assignment packets now. So, so I'm just going to hit enter on that. And then it should output a list of immediate assignments. for GPRS and just like phone calls and SMS and stuff like that. So yeah, that's it there. So we can see we've got a number of GPRS packets because I was using a data connection at the time. We've got SDCCH immediate assignments. We've got some traffic channel assignments here. So yeah, very, very cool little feature. All right, we've got one more feature I'm going to show you guys now. And that is Timsies. So Timsies can be a helpful tool when you're decoding GSM because every phone or mobile device on a GSM network gets assigned a Timsy, and you can follow that Timsy, and you can use the Timsy to identify traffic in within your capture file. So to extract the Timsies from this BFILE burst file, we can run the following command here. I'm going to put all these commands like in the pinned comment or the description below. So we can see in the background, it's actually decoding the capture file again. And then here we go. We've got 2 Timsies, and it gives us so Timsy is a temporary mobile subscriber indicator or something like that. I think I should know, or identification. I should know what that means, but I don't, unfortunately. I'm not prepared. Sorry, guys. No script these days. Yeah, so we've got 2 Timsies here. One of them, so these would obviously be my 2 smartphones. And yeah, it just gives us how many times this particular IMSI showed up in the capture file. So yeah, that's all the features I've gotten working from GSM Assessment Toolkit. Unfortunately, I wish I could get more of this stuff operational for you guys, but yeah, it's hard to play around with this stuff, unfortunately. So yeah, I hope you guys enjoyed that video. Yeah, that's really all I've got for today. So yeah, thanks very much for watching. Bye.